In this chapter, you have a digitization concept, need, methods, and equipment. This is the unit of your study. Now here, uh, we'll see digitization basic definition, need for digitization, selection of material for digitization, steps in the process of digitization, scanning, indexing, storing, retrieving, digitization input and output options, scanning as imageable, optical character recognition, OCR, and retaining page layout using Acrobat capture, rekeying, technology of digitizing, bit depth or dynamic range, resolution, threshold, image enhancement, compression, lossless compression, lossy compression, uh, compression protocol, file format and media type, format and encoding used for text, tools for digitization, scanning software, digitization of video, designing digital image, digital library software, planning and implementation, feasibility, planning the project, purchase of hardware and software, selection of material for digitization and bond digital, placement and training of manpower, content creation, execution of the project. These are the components we're going to cover in this chapter. Now, what exactly digitization means? Digitization means nothing. We are just converting the um, any handwritten material or analog kind of analog material into digital form. Any normal material which has been written somewhere or something, some photograph which is completely manual, we are converting it into the bits and bytes. So that's basically that is meant digitization, right? So digitization is a process. If we just process a picture, we'll just scan the picture. We'll scan the picture and we'll convert it into the pixels, right? So so either it could be a document, could be a photograph, could be a audio, video, which is sometimes it came in analog. We are just converting into bits. So that's basically a concept of digital materials. Now here you can say digitization refer to the process of translating a piece of information such as books, journal, articles, sound, recording, picture, audio tape, or video recording, etc., into bits. Bits are the fundamental unit of information in a computer system. Converting information into these binary digits is called digitization. So you are just converting this manual thing into the digital format. That basically a digitization. Now, why we go for the digitization? What is the need? The quality of preservation. It's bring a better quality of the product. Suppose a books. Uh, Sometimes you will find it cannot be so much of durable. But if we go for the digitization, the durability and preserving quality has always extended. Then multiple referencing. The important part of that, if one printed book can be shared by one person, but if we take one digital copy of a book that can be shared by many people, sure, multiple referencing is possible, which is cost effective indeed. Then wide area usage. If by creating one digital copy, it can be used in several places. Archival storage, you can preserve it in an archival mode. Then security measure. If it is digital, so it's not going to stolen, not going to uh, kind of thing. Nobody can damage it. So the security of the information has increased in that. So digitization is required. Now, selection of material is important. If it is audio, what type of audio we're going to take, then video, uh, what type of video we are going to select for the digitizations, then photograph, it's another important aspect. What will be the resolutions, uh, what will be the pixels kind of thing. So you have to create some kind of standard for that. In case of document, you have to see is that we go for the direct image scanning, or we'll go for the PDF, or go for the tipped kind of image. So important is in the beginning of the digitization process, you need to understand how we are going to do the digitization process. Now, what are the steps for the digitization? Step one is place picture on the. Suppose we are going to digitize one particular document. What we'll do, we'll place the picture on the scanner class, start scanning the software, select the area to be scanned, because we're not going to scan the whole, but you are going to scan some portion, or sometimes can be a whole book. Choose the image type and subpin the image, set the image size, save the scanned image using desirable format, GIF or JPG. So this is our basic process of digitization. Now, why indexing is important? Suppose you are digitize one particular document. If and that particular document is almost like an image kind of thing, if it is not PDF or T. So when it's image kind of thing, so we need to create a proper keyword for that for searching, because digitizing is not important. It's a very simple thing that you just put a camera or scanner, it will digitize it. But at the same time, you need to understand whatever you are going to digitize, it need to be accessible by the users. When you are thinking of doing accessible, you need to create some kind of indexing policies for that. And for that indexing policies, keyword, title kind of thing, which is important for that accessing of that particular document. Now here you can understand there the one component, author, title, keyword is important for a particular document. But at the same time, if we have an keywords, image, this is a one line. Now this is image and this is a location of the image. Now here is keyword, the keyword predicting same image, and if you are searching that particular image with the keyword, it will search that image. This image will refer the location, image location path. Now this is possible because, and this is normally because when you are thinking of creating kind of indexing, so you are creating a particular file for index. So you are representing keywords, and keywords will link with the location of the image. So when you are searching image on biodiversity, so in the computer or in the Google, so biodiversity is a terminology. It will going directly to the Google index, and Google index immediately go to the image file, and whatever image is taking from on the biodiversity is bring back to you. That's basically the process. Now, many DMS, digital management software package, provide OCR read capabilities for transforming the image into standard ASCII file. The OCR read text then serve as a database for full text search of the stored image. Now, storing. So digitization is another important. So you are creating index for that because you are going to identify one particular image with a specific keyword. Now, storing another important. Where we are going to store it, because normal computer hardware, hard disks is not a secure place for keeping all digital material. You have to have put into either CD-ROM or DVD or magnetic discs, optical disc. So whatever the digital document will come up, you will create, you need to store somewhere in a safe place. That's the policy of digitization. Now retrieving. So retrieving and is another important aspect. So if you do not have a proper index, you cannot do the retrieving. Suppose a simple image cannot carry any kind of text on that. And suppose one particular image is just a pixel. It doesn't carry any particular thing, any particular item, which through you can search that unless the file name of that particular image. So in normal JPG or kind of file, you cannot go for the direct retrieval. So you need to think, if it is image file, then we'll put one particular title of that particular image. If it is document file, then we'll go for the PDF or TIFF. So the everything can be searchable. Now, for the searchable, you can use Boolean logic, proximity search, or any other. But retrieving, it's directly connected with the index of your file. Now, digitization input output. A document can be converted into a digital format depending on the objective of the digitization and end user availability of finance. So when you are thinking of digitization, then three important pillars you need to be careful. Now, scanning as image only, there the steps are there. The OCRing and retaining page layout, retaining page layout using Acrobat capture, and rekeying the data. So these four components we'll see one by one. Scanning as image only. So we have already discussed that when you are thinking, this is the most easiest thing. Sometimes we do, even you also do, whenever immediately whatever you are watching in your computer, you are just taking picture in your mobile phone. So this is also a process of digitization. Here, what happened? You are you are just clicking. So in clicking, what happened? Suppose after 1 year or 2 years, when you are searching the same image with this concept that on digitization or of Reuther class, you cannot search on in your mobile phone. You have to go one by one, or you have to go one by one with the date. Why? Because in scanning, image scanning, the most impossible task is putting keywords. So file name is another important, but some of the so uh, there are different format is coming up. You can change it, but bitmap image or JPG image, it is impossible. That's why scanning only image is not feasible in digitization. So through OCR, it can be possible. If OCR is not carried out, what happened? The document is not searchable. Most of the scanning software generated TIFF format. So when you scanning one thing, it's scan first TIFF, TIFF, which can be transformed later on with the PDF. And if it is PDF, then it is searchable. Even you can search a page one by one. That's the most important feature. Now, here in optical character recognitions, here you can see, suppose I am scanning this particular document, JUDAS, press it. Now, if we scan it in OCR, it will come like that. Sometimes what happens, suppose 3 is not written properly. So in that case, these 3 can be look like 8 or 0. So editing is important, right? So editing is important. That is basically concept of optical character OCR recognition. Now, retaining layout after OCR. So when you are scanning something, you have to keep everything as it is, the total layout of that particular document. That can be possible. OCR text recognitions is processed electronically identifying text in a bitmap page, image set, image generate file containing the text in ASCII code. So this is another important task. So when you are scanning in OCR, you have to retaining the layout, right, of OCR. Retaining page layout using Acrobat capture. The latest version, both the Xerox and TextBridge and Carrier, OmniPage, incorporated technology that allow option of maintaining text and graphic in their original layout, as well as plain ASCII and word processing format, right? So that can be output through the HTML or HTML, I think. So you can understand the Xerox TextBridge and Carrier OmniPage. You can edit even in PDF. Some of the PDF editor is also available. You can edit on that. So this additions is because you want to retain the everything into the document. Page layout Acrobat in Acrobat is more feasible. So you can create image and text. You can create PDF as normal. That is possible through Acrobat Capture 2.0. That's probably one of the finest Acrobat PDF editor software. Now, rekeying, a classic solution of this kind would comprise of keying in a data its verification. This involves a complete keying of the text, followed by what exactly the keying means. Uh, Suppose after scanning, you have to corrected error into that. Suppose you scanned one page, and in one page you will find 90% or 92, 93% are more accurate, but you have to create 100% accurate. So 100%, if you go for the 100% accurate, then you have to do rekeying. Rekeying means nothing, it's a proofreading, and you have to omit the error. Then what are the technology you are going to use in digitization? Bit depth, dynamic range, resolution, threshold, image enhancement. These are the most important components in the technology of digitization. Now we'll see what is the importance of the bit depth and dynamic range. Now coming to the bit depth, if it is 8-bit, then here you can see you can get 16 crore 1 crore 67 lakh 77,216 possible color. Here you can see the red, green, blue. This is the combination. And if it's 256, 256, 256 into. So in 8-bit, you are getting this much of color. Now, when it's come to the 10 bits, you are getting almost 10 crore, 107 crore, 37 lakh possible color. And here also you can see 1024 into 1024, red, green, blue. This is 10-bit. This is 12-bit, 68 billion possible color, if it is bit is concerned. Now, just think over about the bit depth. If it is here, so bit depth is lesser. That's why it's white. In this portion, bit depth of black pixel is higher. That's why it's getting gray. Here 50-50, here 60-40, here 70-30. So this is where as the bit depth is coming closer, the color effect will be higher. Now look at that example: 1-bit 2 colors, in 2-bit 4 colors, 3-bit 8 colors, 4-bit 16 colors, 5-bit 32 colors, 6-bit 62 colors. This is the way. So when we think of 8-bit, so it's previously in PC in 386, 486, 586, we used to do right that way. We are just taking 8-bit 256 color, then it's immediately comes 16-bit. Now we are almost 24, 64 bits is coming out. 32 bits also there. So this is the way bits are focused on the color of image. Now, what is censoring dynamic of images? If you see through the human eye, its extension is higher. Now, if it is, but any image sensor, either in camera or scanner, it has its own limitation. It cannot be so much wide as the human eye. So in case of photography or image, this is important. Here you can understand the concept. This is 0 stop, -2. If sunshine, it's coming to the dark. Here you can see the effect of sunshine. It's getting darker. Now look at this. This is basically resolution dynamics. This portion of the picture, it's not so clear. Here it's clear. It's looking nice. There's a blue sky. Here you cannot understand the blue sky. It's almost the white sky. So that's a dynamic resolution, a dynamic range. Now here you can see the dynamic range is upward. It's almost like a whole stairs. Now it's a length. length of that. But bit depth is almost a step, right? Number of steps in that particular image. So that is the referencing between the dynamic range and bit depth. Coming up to the resolution of a document, of a picture, of an image, this is accurate, this is precise, this is accurate and precise. This is accurate and precise. This is neither accurate nor precise. So in resolution is concerned, this is important. This is important. Sometimes you will see in many images, if you increase the resolution, it's getting damaged. The photograph is not coming up to the mark. So here you can understand the accuracy and precise is important. If you look at the high precision and low precision, here low accuracy and the high accuracy is the accurate. This is accurate, high accurate. This is more accurate. High resolution in rows, low. This is on low resolution. This is on high resolution. So when resolution is high, you will find more thinner line into the image. Here is 10 ppi DPI, 20 DPI, 100 DPI. You can understand the resolution is concerned. If it is 10, it looks like that in 1 inch. 20, it looks like that. It is in 100, so it looks like that. It's more feasible, most readable. Now, if we talk about the high definition, when you talk about the ultra high definition television in your home, so it's 400 pixels, 720, 2080, and this is ultra high, 3840 into 2160. That's why it's called ultra high, right? So this is a kind of imagination. Then threshold. Threshold is nothing. It's a pixel count. Then pixel intensity. Here you can see the 1 pixel intensity, T1. If it is T2 and T1, this is another pixel intensity. Here also is pixel intensity. You can understand here. Now, this is why this is important, this threshold, because you have to keep your image more lighter. If you go for the lighter, then you have to create such kind of pictorial form, which is threshold kind of thing. So it can refer to a original. Now, this is a concept of threshold. Suppose this picture will take more space in your hard disks, but this picture will take lesser, and it uses lesser ink, right? So that's important. Now, if you look at this figure, absolute threshold, this is a illustration, the detection of the absolute threshold through the method descending limit. Each light is more dim than the one to its left, right? So it's gone dim to dim to dim to dim to. So what you are doing, you are lighting the pictures. It not should be so much heavy, because you have a lesser space in your hard disk. You have to do threshold because to keep more picture, more image, more text into your document. Now, image enhancement, that is another important. It's very much useful in the digitizations. Look at the both. It is not enhanced. This is enhanced. So both are different. In enhanced, in unenhanced, here you can see, you cannot understand what the person is doing. Here you can see, you can understand. Look at the image enhancement. Here it is not so much of clear in this picture, but here it is clear. This is input, and if you enhanced it, this is output. So you can understand the clarity of the picture, how different both pictures are. Then coming to the compression. Now, what is compressions? Here you can understand. In JPG image division, JPG transform compression start by breaking the image into 8 groups, each counting 64 pixels. 3 of these 8 groups are enlarged in this figure, showing the value of the individual pixel, a single byte value between 0 to 5, 255, right? So this is basically compression of a particular image. Here you can see this is original and this is compressed image. Why we required compressed image? Because we have to keep more image into our system. So that's why we need to compress. This is 200 KB. This is 20 KB. That's the basic compressed. Here you can see this photograph of panda. It's bigger, and this is compressed from. Now, when we're going for the compression, so you are reducing the photograph, then you have a two type of concept. It's lossless and the lossy. In lossless, original, compressed and restored. And lossy, original, compressed and restored. Now, losses, Runley, Huffman, Sunam, these are the concepts. These are the standard of that. These are the standard of the format of compression technique. Now, you can understand what exactly the lossless and lossy. This is lossy. That's why this picture is not so much clear. Now here, lossless, it has not, everything is coming up. Everything is coming up. You can see everything of that particular image. Now this is lossless. This is lossy. This is more resolution based. You can see the nail of the bird. Here you cannot see. That's the difference. Now, what is basically the difference between both? The lossless compression, no loss of information. Original data exactly recovered from compressed data, lower compression ratio. Lossy comparison, loss of information. Perceptual loss of information, reduced control, higher compression ratio. So this is all about lossless and lossy compression. This is a lossless and lossy comparison. This is lossless and lossy comparison. Now, compression protocol, here TIFF, JPG, LZW. Now, we'll see TIFF, International Telecommunication Union, ITU Group 4, is considered as de facto standard compression scheme for the black and white or biotonal image. An image created as a TIFF as compressed using ITU G4 compression technique is called Group 4 TIFF or TIFF G4 and is considered as a de facto standard for storing biotonal image. Now I will tell you important aspect that when you think of TIFF or G4, that you are talking about the black and white, right? Monochrome concept. Now JPG is almost, it's a Joint Photographic Expert Group, is an ISO 109181 compression protocol that work by finding areas of image that have some tone, shades, color, other characteristic, and represent this area by a code. So JPG has its own impact, and JPG is more popular. Preliminary testing of indicates that compression of about 10 or 15 to 1 can be achieved without visible degradation of the image quality. That's basically the concept of JPG, and we are using JPG extensively. Now, LZW compression technique uses table-based lookup algorithms invented by the Abraham Lempel, Jacob G, and Terry Welch. Two commonly used file formats in which LZW compression is used are graphic interchange format and tag image file format. LZW compression is also suitable for compressing text file. So this is also very much useful, but I do not know how many of are being used of that. Then OCR, metrics, optical character recognitions, you all everything know. Then metrics template matching, it has this feature extraction also. It has structural analysis also, and it has also neural networking system. So it can work on, you can transmit the things with the fuzzy logic in the image. Now, what will be the file format and media types? This is another important. Format and encoding used by the text, structural text format, page description language, PDL. These are the concept of media. Then page image format, file format, structural text, ASCII, American Standard Code, SGML, standard generalized markup language, XML, enhanced extended markup language, PDF, portable document format, PostScript, Adobe TS, TX texture format, TXT permission. So it's a present like, so many file you will see it is TXT, text file. Then file format for the images, PDF portable document, BMP, bitmap, IMG, Ventura, publishers, JPEG, GIF, Joint Photographic Expert Group, GF, JIIF, JFIF, CPC, PC, PCP, PCX, it is called PC Paintbrush, PCX, PSD, Photoshop, PSD, TGA, TrueVision, Traga, TGA, PNG, Portable Network Graphic. So portable network graphic, sometimes you call JPG or PNG. So you prefer PNG. So PNG is portable network graphic. TIP, tagged image file format. TIFF G4, tagged image file format with group 4. Fax compression, TIF. SIPFF, ASPIFF, still photography interchange file format. SPF, PCD, photo, CD, PCD, right that way. Now, in audio format, you have a WAV, you have a AIF, you have a VOC, if I have a MIDI, you have a SND, you have a AU, then you have a RA, then AVI, FLA, FLC, FLA player is sometimes called, then movie, MOV, then MPG, then MP2, MP3, right that way. This is on audio video. Now, probably we have a MP4. So MP3 nowadays we are using for the audio, but MP4 we are using for video. Now, tools for digitization. So these are the standard. Now, what are the hardware will be? So scanner, you have a different type of scanner. Scanner is very important part because without scanner, you cannot go to that. So what is the function of the scanner? So lens will come up, it's lamp, this is mirror. So any things we put on that, it will scan through the mirror. So this is almost like that. This, if you put one books over there, it will scan the document. Now you have a many scanner, a flat belt scanner, sit, fit sits, sit fed scanner, drum scanner, digital camera, slide scanner, microfilm scanner, video frame grabber, handheld scanner. These are the different type of scanner. If you look at this is sit fed. You just put the sheet or paper on that, it will automatically digitize. This is drum scanner. You just put the document like in this drum, it will automatically digitize whole the document. Even in many institutes are using the digital camera for digitization. They click, then they clean, then they convert it into PDF. Then slide scanner. This is a slides. This slides through, you can see and you can scan the document. This is microfilm scanner. Through this, microfilm can be scanned. Then video frame grabber. If you want to grab any kind of video frame, analog to digital, this is possible through this system. This is handheld scanner. If you just scan, just swap that particular handheld scanner, it will automatically take out the whole picture of the document. This is flat belt scanner, right angle prism, overheaded flat belt. This is the most popular. Here we have already know that for analog to digital, we have to go through right that way. This is from analog audio to digital audio. This is analog video to digital video. This is the way we are digitizing the things. Now, organizing digital image, descriptive, the important aspect is that how you are going to arrange all those documents. One is you have to use the descriptive metadata. Without metadata, you cannot create a proper indexing or retrieval process. If it is administrative or technical metadata is very much important when a concept of digitization. Suppose a doctor never asks a document or never retrieve a document with a child medicine. He will write pediatric carcinoma. So when you are doing something on medical science, you have to use the technical metadata. You have to use the technical thesaurus or technical dictionary. Then structural metadata is important. If we do not go with the structural metadata, it cannot be coined with the linked uh, concept retrieval system, right? Then digital library softwares are there. Then you require a digital library softwares. Then you have a Greenstone, DSpace, ePrint, Fedora. This is a Greenstone. We'll do work on that, and we have some videos also in our channel. Greenstone is a more. It can be used in um, Linux as well as the window. You can directly go to the Greenstone pages and download. It has some prerequisite, but most easy and most famous software. And this is DSpace. DSpace is very good software based on the Linux operating system. It's an open source software. Both are open source software. Greenstone is open software. But this software is very much steady. It can create huge number of digital documents. And then come ePrint. ePrint is not so much a popular, but it is also a. Then Ganesha Digital Library also created in Indian environment. There is also very good software, and it can also be run through Windows or Linux both. Then this is the Enlist also. This is also kind of digital library they are also using. But what I am going to say, this is a here in our library, we have created digital library. We have created our own software. We have not gone for any kind of software. So in digital library software, we have given a password. Then you can choose from that cabinet. Then you can search by project with the project name. Then you can click on that. Then you can able to understand the name of the student. Then you can go to the you can search project report also. If you select one project report, it will see like that. This is our PDF format. So without using, this is our National Digital Library. They have also used, but if greater infrastructure, you cannot think of the quantum of resources are available. This is one of the finest project in our country, and probably this is the highest project throughout the world. Now, important is when you are doing digital library, it is not that you need to have a one digital software. It can be done by your own software. You can create. But importantly, what happens when you are creating more digital software, you are putting lot of effort. But if you're using existing software, then your effort and your work can be converted or diverted to the digitization process. So that's why it's always advisable that we have to go with the one specific digital library software. Now, for planning and implementation, you have to plan, you have to study feasibility study, then you have to plan the project, then you have to purchase the hardware software. Then important is selection of material for digitization. And what you are going to include is the born digital. So you have nothing worried about on born digital, but which is not born digital, you have to digitize all those things. And born digital, you have to link with your software. Then placement and training of manpower. Manpower need to be trained, otherwise no project can be successful. Then content creation. Content creation is another important part, because content has digitized. If you not create content, then then execution of the project cannot be possible, because your resource cannot be reached to your user. So this is all about your digitizations of your library.